We are looking into plane geometry, and we are starting with the angles. What is meant by angle? See, angle could be said to be formed by any two lines intersecting at a point. The space between the two measures or gives what we call the angle. Or better still, we can consider a line that is fixed at the point O and being rotated, being moved, either anti-clockwise or clockwise. However, in geometry, angles are measured in what? In anti-clockwise movement. And the zero angle is always considered to be in the first quadrant. Now, if this is rotated, the next moment you can find it somewhere here. If this is A, then we have this to be A prime. The angle generated could be denoted by theta. Angles are measured in degrees. So if I have theta, theta degrees, that is how it is denoted. See, at the upper fix of whatever the symbol we are using to denote the magnitude of the angle. We have different angles. We have angle at a point, the value of which is 360 degrees. If I have this, I could have this. This is 90, it's also 90, this is 90, and that's also 90. 90 times 4 gives me 360. So angle at a point is 360. We also have angle on a straight line. On a straight line. Angle on a straight line, which is 180. Okay, if you have this, 180 degrees. See, this and that, this is A, this is B, this is C degrees. Okay, A plus B plus C in degrees add up to 180 degrees. 180 degrees. And we can use this to classify various angles that we have. We have a right angle. The right angle is 90 degrees. Okay, we have obtuse angle. Obtuse angle, that which is greater than 90 degrees. We have acute angle. Acute angle, X, that which is less than what? 90 degrees. And then we have the reflex angle. Reflex angle. Z is an angle that is less or equal to 360 degrees, but greater than 180 degrees. Now, of course, this tells you various angles we have. And we could have some others too, but these are the major important ones. Okay. Now, from there, we move on to angles and intercepts on parallel lines. Angles and intercepts. Intercepts on parallel lines. First of all, We ask ourselves, what exactly is meant by parallel lines? If you have two or more lines that can never meet, no matter how they are prolonged, they will be considered as parallel lines. So these are parallel lines. Parallel lines. Okay. Now, we can have parallel lines like this, and then we have the intercept. This line AB and BC, CD, and then we have EF. You see, the name given to line EF is either transversal or intercept. Okay, this is the intercept line. Okay, or intercept. Okay. On this, we have angles. Let's denote these angles as A, B, C, D, E, F, G, H. So we can still define some names of angles using these angles. How are they related to one another? When we consider angle G, which is below this parallel line, the parallel indication is given by the arrow, G is equal to D. What is the reason? Why is it so? The G and D are below the clone. If we consider these as ladder and D, so G and D are below this line, and they are on the same side. They are corresponding angles. Angles. This is denoted as angle. So also, F and B. F also equal to B. The same reason. We come to the left side of the transversal. We have H and C. H and C corresponding, just as E and A also corresponding. All right. Those angles are corresponding in the system. We can also look at vertically opposite angles. Vertically opposite angles. And we can list those ones. Vertically opposite angle. What do it mean? Some people, just for us to remember it quickly, at the X angles, this G and E are equal, vertically opposite. H and F are equal, also vertically opposite. So we can begin by saying that A equals D, just as C equals B. This is vertically opposite angles. Okay? So it is this also. When you come to this point, E equals G, just as F equals H, all of the same reason, vertically opposite angles. All right. We can also deduce this. We have Z angles. Let's consider these. Z. It forms Z. This angle here is equal to that angle. And that is alternate angles. C equals F. Alternate angle. Alternate angles. We'll look at it. There are others. Okay? There are others. When we look at this, let's see. See in that. Is there any other? Let's look at something like this. This and that. D and E. D equals E, alternate angle. And this, I'll convince you that this should be equal because C plus D are angles adjacent to each other on the same straight line. So angle on the straight line which is equal to 180, C plus D will be equal to 180. Just as we can see that of E and F, they are adjacent to each other and on the same straight line. So E plus F add up to 180. Now, when you look at this further, G will be equal to D. That is corresponding. Good. We can also say this. The whole angle at a point, the entire angles here, angles at a point, angles at a point. That's another. A plus B plus C plus D add up to 360, just as I said earlier. And so also E plus F plus G plus H also add up to what? 360. And the reason is angles at a point. Those are the kind of angles that we could find there. See, note in the summary, when you have a straight line, any two adjacent angles on the straight lines add up to 180. So we have C and D, E and F, H and G, A and B. All these add up to 180 each. And the whole two or pair add up to 360. That is 4 different angles. Now, from there, let's look at triangles and polygon. By the word triad, which is a Greek word, triad means 3 angles. Okay. Poly means many. So, polygon, sorry, this is G-O-N-S, polygons. See, polygonal figures. So triangles, we have triangles like this. A 3-sided figure, A, B, C. Okay, that is a triangle. We have different types of triangles with different properties. A triangle is made up of 3 sides and 3 angles. Okay. Naming of the side, we have side AB, we have side BC, and we have side AC. Okay. So the triangle there could be named like this, triangle ABC. We have these as an angle. We can name these angles. Angle B. Angle B could be written in these. Angle A, B, C. The middle letter contains the angle. Or it could be written as A, B, that sign, C, tells you that B is where the angle under reference is. Okay. Now, sum of angles in the triangle add up to 180. Note. Sum of angles in the triangle is 180 degrees. Okay. Like I said, we have different types of triangles. We have scalene triangles. Here, none of the three angles are equal. None of the sides is equal to another. Okay, none of the sides is equal to another. Any triangle like that is known as scalene triangles. Okay. Also, we have isosceles triangle. In an isosceles triangle, two sides are equal. Not only that, two sides are equal. The base angles of the triangle are equal. So if I have this means they are equal. This side AB and side AC, they are equal. And this is the base angle. The base on which it sits, this A, and this also will be A. And we can denote it with this single line or a double line that we are using, meaning that the angles there are equal. Those are the properties of isosceles triangle. We can also have what we call the equilateral. Equilateral. Equi means equal. Equilateral, side. Equilateral triangle. Equilateral triangles. Okay? What are the properties of these equilateral triangles? All sides are equal. All the sides are equal. B, all the angles are equal. So over here, since the sum of angles in the triangle is 180, 180 divided by 3 will give us 60. So each of the angle is 60 degrees. 60 degrees. And all the sides are equal. That gives us an equilateral triangle. Equilateral triangle.